Hello, today's lesson is going to be on vectors, and you can follow along in the textbook on page 408 to 409. So what we should know is vectors have been used for translation before, and so you should have seen this, and so this is just sort of recapping on something you already know. The translation from the object to the image is 4 to the right and 3 squares up. This is expressed as a column like this, with 4 to the right and 3 squares up. So this is a column vector, and it fits in with moving the object along 4 and up 3. So that slides it along that vector there, which is marked with that red arrow. So, drawing some vectors, here's some examples that I've done for you, and have a little look. Can we see the first one is a vector 3, 4, so vector P is 3, 4. Vector T goes along 4 and then down 5, so that's 4, negative 5. Vector Q goes back 4, then up 6, because the arrow is really important, showing you which direction we're moving. So negative 4, 6. So as you can see, 3, 4, fitting in with 3, 4, 4, negative 5, and negative 4, 6 for Q there. So that's how we draw some vectors. If you'd like to draw some vectors now, pause the video and try question 1 from page 409. Okay, so moving on to some definitions. So what we need to know about vectors is they have two properties: how long it is, so the length known as magnitude, and the direction of the vector signified by an arrow, which we've already seen. So here we've got two vectors, and they're both A, and you can see they're going in this direction. So they go from like the bottom to the top. So these two vectors are equal in length, they're parallel, they have the same direction. The vectors, as you can see here, are labelled in bold type. Obviously we cannot write in bold type, so we use a little symbol, a little twiddlesy symbol underneath them. So if I'm drawing out a vector, I like to put a little twiddles under there. You can just draw a straight line, but it's good to have something with a flourish. So further definitions, can you see here we've got A, and then we've got one the same length as A, the same parallelness as A, but going in the other direction. That's very important for vectors. So if a vector is equal in length, parallel, but has a different direction, then the vector is negative. So you've got A and you've got negative A. So A going that way, but then negative A going the other way. In this picture, note that the vector has capital letters at the beginning and the end, S and T. It is the vector ST, and we've given it another little lowercase letter, little s. When we write vectors this way, of course, we can't do it in bold type, so we use an arrow to show the direction from S to T, just above there, and the little twiddles there underneath S. If we go T to S, it will be negative S as a vector. And again, that will have an arrow of the T to S and the little twiddles under S there. Further definitions, obviously we can multiply a vector by a number. So if this is P, and this is 2 lots of P, because it's twice the size of P. This one's 3 times the size of P, and this is going in the wrong direction, going in the opposite direction to P, but the same length and same parallel idea. Then we've got negative P. If you want to write some notes on this as well, it's very important that you can do that into your green book, so there's a few notes for you there to take. Here's an example of how we can use vectors to solve problems. So we're going to do some addition and subtraction with vectors, and it just follows exactly the same principles as addition and subtraction normally with numbers. So if we're going to do m add n, we do 3 add 2 and 2 add negative 1, which I've written down here. Look, 3 add 2 is 5, 2 add negative 1 is 1. And then we express it using the column vector notation from there. So we've got the 3 and 2, 2 negative 1, so 3 add 2, 2 add negative 1, which gives us 5, 1, just like we said here. So if we're subtracting, we're going to do the same thing. So we're going to do 3 subtract 2, and then 2 subtract negative 1. Just being careful, obviously, when you do subtract a negative, it becomes an addition, so that'll be 2 add 1 is 3. And again, using the columns, we can now do 3 subtract 2, 3 subtract 2, which is 1, 2 subtract negative 1, 2 subtract negative 1, which is 3. So if you'd like to try just adding and subtracting some vectors, you can now pause the video and try question 9 from page 409. So next one is drawing pictures. So it's the same scenario. We're doing m add n. So there's the vector m, 3, 2. Adding n follows on, goes exactly the same direction as that. So 2, negative 1, giving us m add n in total, look, which is the same 2, 4, 5, 5, 1, which we worked out before. If we're doing m subtract n, we've still got m going in the same direction, but then n, because we're going in a negative direction, we have to put it this way on, following the wrong way. So you get m subtract n, which was 1, 3. If you want to try drawing some vectors for pictures and subtraction, now you can pause the video and try question 5 from page 409. Just a little parallelogram example now. So if we've got a to d, or d to a, sorry, is a vector, I'm calling that a, and the vector a to b is b. What is the vector c to b? This vector. And what is the vector c to d? So this way on. So c to b is parallel to d to a, and it's the same length as d to a. So that vector is exactly the same, that is a. What is the vector c to d? Well, c to d goes in a different direction to a to b, so this is a positive direction there, so this way would be negative, so this is negative b, because they're parallel, the same length, but going in opposite directions. So at this stage, there's questions to complete there. Complete questions 1, 9 and 5 if you didn't pause the video, and then try questions 4 and 3. And that should be the end. So good luck.